So here we have a triangle, and this triangle, of course, is set up in the what might be ambiguous case here because we have the first angle A. I'm just going to draw a 45. So this is a 45 pretty much. So 40 is just lower than that. This is going to be our angle A, and then the side length AB is going to be 2. So this is going to be AB here. And then our final side length BC is 3 units. So this is 2 units. So I'm going to draw just a little bit longer than that, and then like that. So this is going to be 3 units. And so this is 40 degrees. So this would be the ambiguous case, but there's a couple things here that we have to keep in mind. That the ambiguous case only happens when this side length ends up being smaller than this length, but larger than the height. The height here is going to be sine 40 times 2 because sine is opposite over hypotenuse. So if we just do that in the calculator real quick, we get the sine 40 and then times by 2. I get 1.28. So that's the height here. It's just about 1.28. So of course 3 is bigger than that. But this third side has to be smaller than this side. And you can see kind of why right here. If you can draw somewhat of an accurate graph, then you can kind of figure this out. Right? 3, for this to actually be to work, this thing would have to be a little bit longer like this. If my graph is accurate. And the ambiguous case means that this thing swings to the other side, and this would have to be like this to be a second triangle. It'd have to be something like this here. The issue is that this triangle, right? This triangle doesn't use this 40 degrees. It uses this angle here, which is going to be 180 minus 40, 140 degrees. That's a different triangle completely. So we know that this can only be the, only have one answer. You can also see this using law of sines. So for law of sines, right, we would have sine of 40 over 3 equals sine of, and then this is going to be sine of c here because we have this side length 2. So sine of c over side length 2. Okay, I'm going to multiply 2 over to get sine of c. So that's going to be I get sine of c equals 0.4285, and then take the inverse sine, or the arc sine. So arc sine 0.4285. That gives me approximately 25.37 degrees. So we already know that A here is what it looks like. But if you wanted to see if it's the second triangle, what we do is we take 180 degrees minus what we just found, 25.37 degrees. And that's going to give us, well, that's just approximately, it doesn't really matter, the number. And you'll see why. It's going to give us approximately 155. And 155, if that was an angle in this triangle, then that means it would also have to include the angle of 40. But 155 plus 40 is 195. And that is already too large for a triangle to have in it. So we know this only has to have one case. And that's an angle of 25.